In this video, we will see about series RLC circuit. So, resistor, inductor and a capacitor are connected in series across the applied voltage Vm sin omega t. So, all these three components are in series, so the current remains the same. And voltage across the resistor will be in phase with the current, and in case of an inductor the voltage will be leading the current by 90 degree. In case of capacitor the voltage will be lagging the current by 90 degree, and the resultant voltage is equal to sum of all the voltages. Now let us draw the voltage triangle. So V is equal to VR plus VL plus VC, which can be written as I into R plus, what is VL? I into XL. You will get a J component because VL will be leading the current by 90 degree. In case of a capacitor, the voltage will be lagging the current by 90 degree. So you have to use minus J. So V is equal to I into Z, where Z is equal to R plus J into XL minus XC. So this is the magnitude of the impedance, and angle is given by tan inverse of imaginary part divided by real part. So let us draw the triangle. So first take I as reference. VR will be in phase and VL will be 90 degree leading the current, and VC will be lagging the current by 90 degree. So VL minus VC will come here because we have taken VL greater than VC. So VL minus VC will be here. Suppose VC is greater, that is VC magnitude is greater than VL, your triangle or your voltage will be here. So the resultant voltage is equal to VR plus VL minus VC the whole square, and tan phi is equal to VL minus VC divided by VR, or XL minus XC by R. Now we will draw the impedance triangle. So in rectangular form, impedance is given by R plus J into XL minus XC. In polar form, it is Z angle of phi. So what is Z? R square plus XL minus XC the whole square, and phi is tan inverse of XL minus XC divided by R. So there are two cases, XL greater than XC or XC greater than XL. Two cases are there. So if it is XL is greater, it acts like a RL circuit, and if XC is greater, it will be like a RC circuit. So depending upon that, your triangle can be up or down. And power factor is cosine of the angle between voltage and current. So this is R XL minus XC, and this is Z. Cos phi is equal to R by Z. And power triangle, active power is I square R watts, reactive power is I square XL volt ampere reactive, and apparent power is equal to I square Z. So this is the power triangle in case XL is greater than XC. If XC is greater, you may get it in reverse direction. S is equal to root of P square plus Q square. So the waveform, you can see voltage and current. Depending upon XL is greater or XC is greater, the current leads the voltage or current lags the voltage by angle phi. So we can write V is equal to Vm sin omega t, and I is equal to sin omega t plus or minus phi. So you will get plus sign in case XC is greater, that is capacitor is more, you will get this one, or when the inductive reactance is more, you will get a negative sign. So the points to remember here are V equal to Vm sin omega t, I equal to Im sin omega t plus or minus phi. Negative sign if the current lags the voltage and positive sign when the current leads the voltage. And Z is equal to root of XL minus XC the whole square. So if XL is equal to XC, if both are equal, this becomes 0. So Z is equal to R. So it becomes a resistive circuit. If XL is greater, it will be an inductive circuit and the power factor will be lagging or the current will be lagging. In case XL is small, it will become a capacitive circuit and you will get a leading power factor. So power, active power, reactive power and apparent power are there. It can be plus or minus. Q can be plus or minus depending upon the XL and XC values. Let us see a problem. Here a coil of resistance 10 ohm and inductance 0.1 Henry. So this dotted line shows a coil. So this is a single unit which has a resistance and an inductance. Connected in series with the 150 microfarad capacitor across a 200 volt supply. We have to find all these values. So the given data is here: voltage, frequency, resistance, inductance and capacitance. Now we will find what is inductive reactance and capacitive reactance. XL is equal to L omega. What is omega? 2 pi f into L. Make sure the unit is henries for L and for capacitor it should be in farad. Here it is given in microfarad. So while substituting for C, you have to multiply by 10 power minus 6. So you can find XL and XC easily. So Z is equal to root of R square plus XL minus XC the whole square. So what is I? V by Z. So V is given, Z we have found out. We can find what is I. So we have found XL and XC. XL is 31 ohms and XC is 21. So XL is greater. So it is a lagging circuit. So let us calculate the power factor. Cos phi is equal to R by Z. So R, Z, you will get 0.7. So it is a lagging circuit. The voltage across the coil. What is a coil? It is a combination of resistor and inductor. So I into ZL, that is the impedance of the coil. So we have to calculate this impedance, that is equal to R square plus XL square. So it comes around 32.95 ohms. So the voltage across the coil is equal to I into ZL, that is 461 volt. Voltage across the capacitor is equal to I into XC. So I into XC. So this is the voltage across capacitor. So write down all the answers. So if you like the material, do subscribe to Read Electric Vehicle channel. Thank you.